चलो, so the first problem beta. Question number 1. 1 mole of a gas, 1 mole of a gas having gamma is equals to 7 by 5 is mixed with 1 mole of a gas, 1 mole of a gas having gamma is equals to 4 by 3. Okay, tell me what will be the gamma of mixture? What will be the gamma of your mixture? Okay, so here you need to remember the formula, that is very important bit. Gamma of your mixture will be equal to how much beta? Formula is gamma of your mixture is equals to Cp1 plus Cp2 divided by Cv1 plus Cv2. Because he has given me the two gases, that is the reason I'm taking 2. Now see here, for gamma is equals to 7 by 5, Cv1 will be equal to how much beta? It will be R divided by gamma minus 1. So it is equals to how much for me? R divided by 7 by 5 minus 1. So this will be equal to 5R divided by 2. Okay. The same way Cp1. Cp1 will be equal to gamma into R divided by gamma minus 1. So gamma value is how much for me? 7 by 5 multiplied by R by gamma minus 1 is how much for me? 5R divided by 2. 5 and 5 will get cancelled. So it is 7R divided by 2. The same way, for gamma is equals to 4 by 3, Cv2 will be equal to again R divided by gamma minus 1. So it is your R divided by 4 by 3 minus 1. It is 1 by 3, so it is 3R. Done. The same way, Cp2 will be equal to gamma into R divided by gamma minus 1. So it is gamma into your gamma value is how much beta? 4 by 3 into your 3R. So this 3 will get cancelled. So this will be equal to 4R. So can you see this formula? Gamma of your mixture is equals to Cp1 will be equal to how much beta? Cp1 will be equal to 7R divided by 2 plus Cp2 will be equal to how much for me? 4R divided by Cv1 will be equal to how much I got? Cv1 is 5R divided by 2. So this is 5R divided by 2 plus of your Cv2. Cv2 is how much for me? 3R. Simplify this one, see how much I'm getting. Anyone? Make it fast. So one student has given me the answer 15 divided by 11. Very good. Sure. Next question. In an adiabatic process, in an adiabatic change, the pressure and temperature of a monoatomic gas are related with relation P directly proportional to T power C, where C equal to how much? First option is 5 by 4, 5 by 3, 5 by 2, 3 by 4. In an adiabatic process, given relation is right now P T to the power of C. Okay. Now tell me what is the relation between P and T beta? Gurtunda, P to the power of 1 minus gamma, T to the power of gamma is equals to constant. Therefore, given equation is P is equals to K, T to the power of C. So T to the power of C will be equal to how much for beta? Minus of your gamma divided by 1 minus gamma. Now see, compare with the given equation, beta. For monoatomic gas, for monoatomic gas, gamma value will be equal to how much for me? 5 by 3. Therefore, if I'm comparing with the standard equation, P is equals to K T power C, C value is equals to gamma divided by 1 minus gamma. So it is equals to how much for me? Minus of your. For monatomic gas, it is 5 by 3. So minus of 5 by 3 divided by your. It is 1 minus of your 5 by 3. See how much I'm getting there.
Five by two.
5 by 2. That gives the answers. Sort of. Done? Sure. See this question. The change in internal energy, the change in internal energy of a thermodynamical system, which has observed 2 kilocalorie of heat and done 400 joule of work. How much? 400 joule of work is dash. In the bracket, you take 1 calorie is equals to 4.2 joules. Okay. First option is 2 kilojoules. Second option is 8 kilojoules, 3.5 kilojoules, and 5.5 kilojoules. Chalo, how much you are getting is the change in internal energy of a thermodynamical system which has observed 2 kilocalories of your heat and done 400 joules of your work. That means Q is equals to 2 kilocalorie. That is equals to 2 into 10 to the power of 3 into 4.2 because 1 calorie is equals to 4.2. That will be equal to 4.2 to 4 to the 4, 4 to the 8. So this will be equal to 8400 joules. And work done is given how much better? Work done is given as me 400 joules. Is asking the internal energy. Apply the first law of thermodynamics. Delta Q is equals to delta U plus delta W. Okay. So therefore delta U will be equal to delta Q minus of your delta W. Delta Q is 8400. Work done is equals to 400. So that will be equal to how much for me beta? 8000 joules. So if it is 8000 joules means it is 8 kilojoules will be the answer. Clear beta? Sure. Tell me the answer for this question beta. The amount of heat energy radiated, the amount of heat energy radiated, by a metal at a temperature capital T is capital E. Okay. When the temperature is increased, to 3T, energy radiated is first option is 81E, next one is 9E, third one is 3E, and fourth one is 27E. Can anyone better? आ गया बेटा? Am I clear with this question? Sure. Yesterday I did this model button heat transfer. You just try to do this question, everyone. We got three rods of same dimensions, have thermal conductivities 3K, 2K, and K. Okay. They are arranged as shown like this. Okay. This is your 50 degrees Celsius. This is 0 degrees Celsius. This is your 100 degrees Celsius. This is 3K. This is your 2K. And this one is your K. There is a flow of your heat from here like this. And it gets divided here. It will go to here and it will go to here. Okay. My question is, what will be the temperature of the junction? What will be the temperature of junction? Can anyone? Last session I told you this model, how to do it out. Incoming current must be equal to outgoing current. That is total heat H must be equal to H1 plus H2. From here it is H. This one is right now, say for example of your H1. This will be equal to H2. You know the H formula beta? H is nothing but what beta? dq divided by dt. It is nothing but K into A into temperature difference divided by length of the conductor. All of them are having same dimension. So same area, same length. So it will depend upon only the thermal conductivity. First one is right now 3K into temperature difference. Temperature difference is how much better? It is temperature here is right now T. Final temperature minus initial temperature. Isn't it? So now it is going from your higher temperature to your lower temperature. Na beta? T final minus of your T initial. Okay. Delta T. Whenever you are writing here, so it will be T minus of your 100. Isn't it? Into area of cross section, length will be same. That is equals to 2K into your this will be equal to final temperature is 50 minus of your T plus of your K into 0 minus of your T. Area and length are same, but I am cancelling that one on either side. And everywhere K will also will get cancelled. Isn't it? So this is 3T minus of 300 is equals to this is 100 minus 2T plus of your T. So all the T's you can take on one side better. So this 3, 4, 5, 6. So it is minus 300. So it will come here 100. So it will become for me 3T minus will come here right now for me plus 2T. And here it will be equal to T. Okay. So that will be equal to 100 plus of
T, sir.
300. Clear?
Sir, minus T.
Which one better?
After is equals to 100 minus 2T plus T, no? Then minus T here, no, sir.
Yeah, this will be your minus T. Isn't it? So this is minus 300 is going on this side. And this will be equal to your 100. Minus 2T will come here. This one is your plus. So this will be equal to how much? This temperature is minus T, na beta? This one is minus T, na? Because 0 minus T is nothing but minus T, na beta? So plus minus minus. This will become for me 100 minus 2T minus of T, na? It will become.
Yes, sir.
Isn't it? So this will become how much for me? 60. 60 is equals to 400. So T will be equal to how much better? 400 divided by 6. That means it will be 200 divided by 3 degrees Celsius. That will be the answer. Clear?
Yes, sir.
Sure. See this question. The power factor of circuit shown is of circuit shown is. This is a given figure. There is a capacitor. There is a inductor. There is also a resistor. Resistor is R is equals to 40 ohms. An inductor XL is equals to 100 ohms. And in resistance of this one is given as 40 ohms. That is connected to your AC source. AC source potential is 220 volt and frequency is 50 hertz. Capacity is XC. XC is equals to 40 ohms. Options are 0.2, 0.4, 0.8 and 0.6. Shall I try? What is the power factor beta? Did you remember the power factor formula? Power factor, what is right now? What type of circuit? RC circuit. So for power factor, what is the formula beta? Cos phi is equals to R divided by Z. Isn't it? Resistance is how much beta? Can anyone tell me? What will be the resistance here? What will be the resistance? What is capital R? How do you calculate Z beta? Z is equals to under root of your R square plus of your, this will be equal to your XL minus of your XC. XL is 100 ohms, isn't it? And R is right now for me how much? 40. So what is the value of R beta? Can anyone tell me? What is the value of R?
40.
No. That is the reason I
Yes,
given this question.
series combi.
This 40 and there is also resistance for this one. This is also 40. 40 plus 40, it will be 80.
Yes.
That is a mistake you'll be doing there. So generally the students take 40 and start doing the problem, but he has also given the internal resistance for the inductor. So the two are in series. So resistance will be equal to 80. So it is 80 whole square. That's only the thing you need to remember in this one problem. Plus this one is 100 minus of your 40 whole square. So it is, this is how much for me? 8 8 is 64. 100 minus 40 is nothing but 60. 6 is 36. So it will be equal to 10,000. That means it will become for me root 10,000 means it will be equal to your 100. Antena? 8 8 is 64. 100 minus 40 is 60. 6 is 36.
Yes, sir. 36.
36 it is 0000. That means it will be equal to 100. Clear? So cos phi is equals to here 80 divided by 100. Generally student will write here 40 divided by 100. Okay now? So this will be 0.8 will be the answer. Clear? Clear beta? Yeah. Chalo. This question. The primary and secondary coils. The primary and secondary coils of a transformer have 50 and 1500 turns respectively. Okay. If the magnetic flux, if the magnetic flux, the magnetic link with the primary coil, link with the primary coil is given by phi is equals to
नजर उठा के ना देखिए वो कितना बुरा, मेरे को कितने दिनों तक मैं नहीं भूलूंगी वो। देखो अब आदमी के सामने बोलते आया तो
phi is equals to how much beta? Phi naught plus 40. Okay. Flux is equals to phi naught plus of your 40, where phi is in Webers. where phi is in Weber. Okay, T is in second and phi naught is constant beta. Phi naught is your constant. The output voltage is how much? The output voltage across secondary coil. Across secondary coil is, read the question carefully, but a good question. Number one, it is 120 volt, 220 volt, then 30 volt, then 90 volt. First read the question. Primary and secondary coil of a transformer have 50 and 1500 turns. That means number of turns of primary is equals to 50. Number of turns of secondary is equals to 1500. Now he has given me in the problem flux. Flux is equals to phi naught plus 4 into T. For which one better? Primary. So I can calculate the potential of the primary. Vp is equals to minus of d phi by dt. I'm taking magnitude. Phi naught is a constant. Differentiation of 40 will be equal to 4. So it will be equal to 4 volt Vp. Okay. We need to calculate Vs. So what is the formula better? Vs divided by Vp will be equal to Ns divided by Np. I hope you remember this formula. So it is Vs divided by Vp is 4. Ns is equals to 1500 divided by 50. This one and this one is gone right now. 5 ones are, 5 threes are. So this will be equal to how much? Vs is equal to 3 4s are 12. It will be equal to 120. Got it? Am I clear?
Yes, sir.
Sure. Here the thing was very important. He has given me this flux. Flux is equal to phi naught plus 40 associated with the primary. So from this flux, applying the Faraday's second law, E is equals to minus of d phi by dt. So we are differentiating. Phi naught is a constant. Differentiation of constant is 0. Differentiation of 40 is nothing but 4 will come out. Dt and dt will get cancelled. So potential of the primary potential will be equal to how much? Or 4 volt. That is the only thing you need to remember in this one. That's next question. The RMS value of the RMS value of the electric field. The RMS value of the electric field of the light coming from the sun is 720 Newton per Coulomb. Okay, the average total energy density of the electromagnetic wave is how much? Options are 6.37 into 10 to the power of minus 9 joule per meter cube. Second option is 81.35 into 10 power minus 12 joule meter inverse cube. Third one is 3.5 into 10 to the power of minus 3 joule meter inverse cube. Fourth one is 4.58 into 10 to the power of minus 6 joule per meter cube. The only thing is you should have been remembered the formula of your energy density. Electromagnetic waves will be damn surely getting 1 or 2 questions better. The RMS value of the electric field of the light coming from the sun he has given me. Electric field is given for me. Average total energy density, that means U. U is equals to half into epsilon naught into E square. Am I clear? He has given me the RMS value. Then how do you calculate the value of your E naught beta? ERMS is equals to E naught divided by root 2. So E naught value will be equal to root 2 into ERMS. So it is equals to root 2 into ERMS value is how much beta? 720. So energy density is equals to half into epsilon naught into E naught is equals to root 2 into ERMS square. Isn't it? So it is root 2 will get cancelled. This 2 and this 2 will get cancelled. So it is epsilon naught into ERMS square will be the epsilon naught value is how much for me? 8.85 into 10 to the power of minus 12 into ERMS value is how much better? 720 whole square. Simplify this one, we'll get the answer. So it is 8.85 into 10 power minus 12 into 720 into 720. So just simplify it, we'll get the answer for that. Okay.
Sir, option 4.
Option 4, Ara. Very good.
Yes.
Sure. Then, what is date today? Hmm?
Yes, sir.
What is date today?
Date, sir.
Hmm.
25.
So how many days are left out for you?
7, sir.
Are you writing your EPSET exam better?
No, sir.
You have not applied for EPSET?
No, sir.
Others? Tanmay, Niharika, Mayuri, Juhi,
Writing, sir.
Asunara?
Yes, sir.
Okay, very good. ఇప్పుడు ఈ 4-5 days ఏం చేద్దాం సజెషన్ చెప్పండి ఒకసారి. I can revise you complete or expected chapters also better. Like say 12th class, I'm having the revision of all these chapters in one stage. I'm planning better, like ray optics and optical instruments, wave optics, dual nature of matter, atoms, nuclei, and semiconductors. In one stage, I'm planning to completely revise all the formulas and some quality questions on this one. If you are interested, I'll fastly revise these all questions once better.
Yes, sir. We will do.
So we'll try to do, you need to just take some time. We'll try to take such a time which will not disturb your regular working schedule and my working schedule also. Tomorrow is Saturday. Sunday, what we can do is we can make it little bit early in the morning, like 5 o'clock, morning 5 to 6, 6 to 7, 7 to 8, or 3 hours. So in my house also everyone will be sleeping, so no one disturbance for me. And if you can able to take the risk to get up early in the morning, 5 o'clock to 8 o'clock or 9 o'clock, we'll try to see that these topics have been done. In this topic, if you are seeing what is the scoring number of questions we will be revising is in that one day. We mostly revise with ray optics is 2 questions, wave optics 1, 3, dual nature of matter, radiation, atoms, and nuclei is right now for me 5. Semiconductors and devices 2 to 3 questions. They roughly 5, 6, 7, 8, 9, 10, 11 questions. Better. I've got 10 responded. 10 into 4, that is 40 marks. 40 marks topic we'll be trying to revise in 2 hours and 3 hours. And for this expected chapters, I'll try to select 10 good questions which should be revised, like in wave optics 10 questions, ray optics 10 questions, optical instruments 10 questions, dual nature and matter 10, atoms 10, nuclei 10, semiconductors and devices and logic gates 10 questions. Okay. So theory is already ready, but only thing is we need to take care of your numericals, so that I'll try to select today and we'll try to do the revision of this one. So Sunday, if we can plan, we can be revising all 40 marks at a stretch. Okay, na?
Yes, sir. We will do.
Okay, this all the things, everything is revising in this one. All the formulas have been coming out, so we need not bother about anything. And remaining magnetism and electrostatics also, I'm having that conditions because these are all the things which we did it 2-3 years back, actually notes. So the same notes I'm trying to recollect it and try to reproduce for you so that it will be easy for your revision. And see how the formulas are there. Today also what we have done is the same, like here's this type of questions require only the formula revisions.
Okay, sir.
Sir, you are in mute.
Okay. In a single slit diffraction, if lambda is equals to 5000 angstroms, A is equals to 10,000 angstroms and capital D is equals to 2 meters. Question is, what is width of central maximum? What is the width of your central maximum? This is what with a single slit now. So this is a single slit. So this will be equal to A. This will be equal to capital D. Okay. And here the light has been going from here. So it is falling on this one like this. So this will be your central maximum. This one. Okay. So width of the central maxima will be equal to your, like say, A into sine theta will be equal to width of central maxima. That means n is equals to 1. So it is lambda. So sine theta is equals to lambda divided by A. So lambda is equals to how much for me? 5000 angstroms divided by this one is 10,000. This one will get cancelled 5 by 10. Okay. So it is 1 by 2. So if it is 1 by 2 means theta will be equal to how much for me? 30 degrees. So width will be equal to how much better? Width will be equal to 2 times of your delta max. That is 2 times of your, this will be equal to how much for me? D into tan theta. Delta y. Because tan theta is equal to what better? Y divided by D, no? Isn't it? So y divided by D. So y is equals to D into tan theta. Width will be 2 times, isn't it? So this is 2 into capital D is given how much for me in the problem? 2 meters into tan of your 30. So 2 into 2, 4 tan 30. See how much I'm getting? Tan 30 is how much? 1 by root 3. So it is 4 by root 3. So 4 by root 3 is how much? 4 by root 3 value is 1.732 approximately. See how much I'm getting. I'll give the options for this one. Options are given as 1 meter. Next one is 2.3 meter, root 3 meters, 2.7 meters.
Sir, it's 2.3.
2.3 meters. Very good. Very. So here very important thing is to understand that it is right now for me what? Single slit diffraction matter and what is the width of your central maxima. A sin theta will be equal to your n into lambda. Isn't it? So sin theta value I got from that one. So I got the value of theta and width will be 2 times of your y. So y value will be equal to how much? Sin theta is equals to y by d. If theta is very small. If theta is larger, we use tan theta is equal to y by d. If theta is very small, so tan theta will be approximated to sin theta beta. Okay, so that approximation you need to remember. 2 into d tan theta, to simplify it, we'll get the answer 4 by root 3. Clear? This question also good question. In a double slit experiment, in a double slit experiment, fifth dark fringe. In a double slit experiment, fifth dark fringe is formed opposite to one of the slits. Opposite to one of the slits. Okay. The wavelength of light used is the wavelength of light is. First option is d square divided by 6d, d square divided by 5d, d square divided by 15d, And fourth option is t square divided by 9. Okay. So see, in the double slit experiment, fifth dark fringe beta. For dark fringe, what is the formula beta? Can anyone tell me? For dark fringe in YDSC, x into d divided by capital D is equals to 2m minus 1 into lambda divided by 2. Here m is how much for me? 5. And x will be equal to how much for me? Because see, in the double slit experiment, this is your slit. One of the wave is exactly forming on this one. This will be central maxima. This distance is right now for me d. So this distance will be equal to how much for me beta? D by 2. Y value. Okay. So x value will be equal to how much for me beta? Here it is right now for me d by 2. So it is d by 2 into this one is d divided by capital D, that is 2 into 5 minus 1 into lambda divided by 2. Okay. So this value will be equal to your d square. This 2 will get cancelled, divided by d. 2 5 is 10. 10 minus 1 is nothing but 9 lambda. So it's asking the wavelength. So lambda is equals to your. So it is d square divided by 9 times of capital D. This will be the answer. Okay. Which option? Fourth one.
Fourth.
What is now? Dark fringe formula is how much for me? X nth dark. X nth dark is equals to 2m minus 1 into lambda into capital D divided by 2 times of your small d. See how simply it was. Only thing you should have been understand that this point was very important to understand that in a double slit experiment, fifth dark fringe has been formed opposite to one of the slit, exactly opposite to one of the slit. That means this distance will be equal to how much for me? This distance from central maxima d by 2. Because total distance from one slit to another slit is d. This one is right now for me capital D. Okay. So that is the reason x value I'm taking it as of d by 2. Simplifying it, we're getting lambda is equals to d square divided by capital. Clear, beta? Sure. I'll send you one grand test paper today right now. You please try to complete that one grand test paper. Okay? Sure. Bye.